Greetings. Welcome back to the Dynamics Foundations series in our Dynamics online course. Today we are looking at video number 3, and now we are moving into some sample problems for each of the fundamental principles. So we'll start with a fundamental principle called kinematics. And kinematics is often seen in both one-dimensional and two-dimensional. In one-dimensional, you might talk about a vehicle that is pulling up to a stoplight. The light has just turned red, and in some number of feet, it has to stop. It has an initial velocity of maybe 55 miles per hour, and it has to stop by the stoplight. What is its deceleration? That would be an example of a 1D. 2D, we often call 2D projectile motion. And in projectile motion, we've got some object that is traveling. Maybe it's launched off of a building. Think of a baseball being launched by a pitching machine off of a building at a certain angle and at a certain speed, and it rises to a certain height, and then it falls to the ground. And there are lots of different things we could ask about that baseball. What is its highest point? How far did it travel? How long did it take to get to any point along the way? So let's do an example problem of kinematics in 2D. And let's start with some object being launched from a certain height. Let's call this height 100 meters. And let's launch the object at an angle of 30 degrees and have the object travel until it hits the ground. One of the things we do in kinematics is we label the points. Let's call this point 0. Maybe call that point 1, call that point 2, and we could have many points along the way. Let's have our velocity initial be 60 miles an hour at an angle of 30 degrees. And let's ask the question, how far does the object travel in the x direction from 0 to 2. So one of the steps here is to make an origin. Let's make an origin right down here at the base of the building and at the ground level. So this we'll call the y direction, this we'll call the x direction, and this will be 0, 0. The equations that we are going to use in our solution. So let me use a given find solution method. Given the picture and situation, and let's say that we are being asked to find x2. In other words, how far in the x direction does the ball land from the building? In our solution, we'll have several steps, and the first step is to recognize which equations we have. The equations for kinematics, there are 3 for the x direction and 3 for the y direction. And we are going to go from point 0 to point 2. So x2, I've got problems here. Here we go. x2, x final, equals x sub 0 plus the velocity at point 0 in the x direction times the time that it takes to go from 0 to 2 plus 1/2 times the acceleration in the x times that same time, 0 to 2 squared. So that's the equation for x2. We would have three other equations for the x direction. Vx2 equals Vx0 plus acceleration in the x times time from 0 to 2. And Vx2 squared equals Vx initial squared plus 2 times the acceleration in the x. From the time from, oops, excuse me, that's not right, x2 minus x0, delta x. All right, so those are the three x equations, and the three y equations look identical, except every place you see an x here, there is a y. And so that gives us 6 equations at our disposal for doing this problem. And when you've done enough of these, you start to get a sense of which equation to start with. What I like to do is start with the equation for position, this equation, in the y direction, and see what my unknowns are. So I'm going to take my solution, and step 1 over here is going to be y2 equals y0 plus initial velocity in the y times time plus 1/2 acceleration in the y times time squared. And I now use something that I like to call the check mark method, where I put a check mark about on everything I know, and I circle the things I don't know. Well, I do know that the position at point 2 in the y direction is 0, and the initial height is 100 meters. The velocity in the y direction will be 60 miles per hour times the sine of 30 degrees. I don't know the time, and I do know 1/2. I do know the acceleration in the y. So the acceleration due to gravity is downward, so negative 32.2 feet per second, and that is the acceleration in the y. And by the way, there is no acceleration in the x. There's nothing causing any forces in the x, and we're assuming now that there is no drag force on this object. In this class, we will start to think about drag or friction forces, but not in this example. All right, so that tells me that the only thing I don't know in this equation is the time, oh come on now, from 0 to 2. If I knew that time, if I solved for it, and I can do that using an equation solver, or I can do it using algebra, then I think I could put it into this equation over here and find x2. Let's check it out with the check mark method. x2 equals x0 plus velocity 0 in the x times time from 0 to 2 plus 1/2 acceleration in the x times 0 to 2 squared. And x2 is what I want. X initial is 0. Velocity in the x direction initially is going to be 60 miles per hour times the cosine of 30 degrees. And the time, if I got it here, I would have it. And acceleration in the x direction is 0, so this whole term becomes 0. So if I do the math for those two, I will have the time that it takes for the ball to travel and That's the time from 0 to 2. And then I will also have